welcome to our session on Open RAN 101, especially in particular for the telco perspective. So we are here to discuss the brief concept of Open RAN and its impact to our network. But before we dwell further to Open RAN, let's go first to our current network now. So you can see here in our picture a cell site. So ito yung ating usual na we can see on cell towers or maybe in roof decks or maybe as well inside malls or other campuses. Yung mga usual sa ating mga ceiling areas. So these are the ones responsible for our signals, for our handsets or our cell phones to deliver services like call and text, maybe browsing, gaming, so on and so forth. So the cell site is responsible for our network since 2G, 3G, 4G, and also 5G to deliver services to our um, fellow people. Yeah. So to discuss what are the components of our traditional RAN, so we have three key components. So we have here a sample high-level diagram to depict the RAN or the traditional RAN. So we have here the antenna. So it's responsible for transmitting or receiving the RF signals to our handsets or devices. Next is the radio unit, wherein it converts the RF signal to to data signal and vice versa, wherein it is being controlled by our baseband unit. So if you can notice in cell towers, we have a small room with telco equipment, wherein it houses this baseband unit. So its function is to process our signals to and from our radio network. So this is responsible for our connectivity to our handsets or devices. So currently, this setup is already this setup. So this BBU or an antenna being managed by telcos and being owned by telco vendors can perform well in our current network, wherein it can cater to multiple services like call and text, uh, and also internet browsing. But in terms of the telco perspective, there's been some, let's say, pain points that telcos globally are experiencing in terms of this kind of setup, in which we're going to tackle later. So with this setup, the current RAN has some characteristics. So first is our hardware, our solution is dedicated, meaning the hardware and software is just in a single box integrated, or we call monolithic. So and usually these telco equipment are costly and has a long life cycle. In which means that whenever there's a, let's say, a new feature in the RAN, hindi siya agad-agad maipapatch sa ating hardware since it is integrated and has a long life cycle. Secondly, the interface in between the BBU and the RU is closed, filled with proprietary configurations in between, in which will prohibit the interop in between other vendors' radio units. So we cannot interop with other vendors' hardware solutions. So for these two characteristics, it will entail for the telcos to be locked in to that certain telco vendor, in which the vendor has full control of the pricing model, its performance, its functions and features, and supply chain. So these factors are one of the pain points that telcos currently are experiencing. And in detail, these are the challenges that we are experiencing for the current brand today. So first, there are a few options. So um, usually the RAN space is being ruled by a select few telco equipment vendors worldwide, and also um, their solutions are proprietary, and which means that the telcos will be locked into that certain vendor. Their solutions are specific to the vendor. So there might be features in a solution that is not available with other vendor solutions. And then usually uh, the licenses in order to cater to services like calling text and data are usually costly in terms of what the vendors are offering right now. And lastly, the features of our current RAN solutions are pre-programmed, meaning you cannot inject a, a feature that is uh, that's open source that will entail more intelligent network. So whatever software you have, that's the only one that you can function to your network. So with these challenges, it will urge or have a push uh, for the operators to to make the network evolve. So currently, we are operating at a DRAM environment. So all of the components, the BBU, the RU, and the antenna are all on site. And in order to achieve Open RAN, there are some steps that we need to take to fully realize its benefits. So first, we need to centralize some components of the radio network. Like for example, the BBU, we can locate it at a more central location to cater to more radio units. Next is we need to virtualize our software, separating it from our hardware, making it virtualized. So that's VRAN. Um, a- and lastly, we need to open up interfaces in between them to make it fully open RAN. So this is the end state that we are trying to attain for operators globally. Now to visualize this evolution, we have these diagrams. So we have here on the left hand side, we have here a traditional RAN wherein it composes of the key elements. So we have the BBU, the RU, and the antenna. The BBU here, as mentioned, is integrated, meaning the hardware and software is in a single box. And in between the BBU and the RU is a proprietary interface called CPRI, or the Common Public Radio Interface. So all of these are from a single vendor. Now we go to VRAN. So for this one, we separated the software component of the BBU to its hardware, making it virtualized. However, the hardware we're using here is still telco grade equipment. So basically, the system is still a single vendor environment, since the interface in between the RU and the BBU is still proprietary. So VRAN is not really open RAN. Now, how will we make it open? So from VRAN, uh, in order to make it more open, we need some things to be done. For example, the baseband software will now be running on a general purpose hardware, or COTS, as they call it. So for this one, any vendor baseband software can now run on an IT based server compared to a telco grade equipment. Next is we will split the baseband unit to two. So we have the CU or the central unit and DU, the distributed unit. So this is more on centralizing the equipment. So the CU will be placed at the more central location, while the DU is placed at the near edge of the network, closer to the RU. So this one, certain functions will be split as well. So the CU will handle higher layer split and the DU lower layer split. And lastly, the interface in between the baseband and the RU is now open with EC3. So with this setup, the promise of a multi-vendor environment, meaning the CU, DU, and RU, different vendors, is now possible. So that's Open RAN. So we we separate the software and the hardware component, and we make the interfaces open. In between them. So Open RAN is based on the concept of segregation, wherein it is separating the hardware and software of a certain infrastructure. Wherein it enables the telcos to have a more flexible and agile solution. For this, we can mix and match our components, picking the best solution per component. And for this approach, we can have a more efficient and a more cost-effective network. So from a monolithic approach, so a black box approach, from this one, we separate the software and the hardware, having different vendors in between. To add for this one, we add a layer of intelligence to our network, hereby automating our network and managing its day-to-day processing of our network. And we'll make the network smarter and software defined, and also to enhance the services that it can offer to our subscribers. So how will this be done in our network? So we have here a sample high-level telco network from our core, access, and to our user equipment. So here is our traditional network, wherein the core and access are monolithic, meaning the hardware and software in a single box. Then we separate the software from the hardware, making it disaggregated, hereby promoting a multi-vendor ecosystem. So for this session, we will focus on the RAN, since Open RAN runs on this kind of concept. Now, with this being said, why Open RAN? What's the value behind? So for Open RAN, it can promote flexibility and intelligence. Since for this one, we can now use general purpose hardware. So we can use the IT servers as our hardware, wherein we can run our radio software on top of the hardware. Also, we can mix and match different solutions, depending on which is the best from the batch of solutions per component. And also, our software is now running on a cloud-native environment, so meaning it's now software-defined and more future-proof, to say. Next is we can now onboard applications to our RAN for new services, especially if there's some new features like energy savings that can benefit our network, and can have further services to our subscribers. And lastly, for Open RAN, it will entail a new skill set for our engineers. So it brings new people, competency, and business models. So with this, Being said, Open RAN can deliver better service to our subscribers, also more innovations to our network, and also to drive down cost to our network as well. So, so that's Open RAN.